Hello everyone, my name is Devin Beeman and we are the Texas A&M University Commerce team. Our project is over the real-time implementation of direction of arrival estimation for coherent and non-coherent RF signal sources. In this competition, our project falls under the unconstrained category. Our advisors are Dr. Nazar Tayem, Dr. Gerald Fudge, and our team members include myself, Taylor Harris, Samuel Gonzalez, Rhiannon Roberts, and Staten McGowan. We are 5 undergraduate electrical engineering majors, and we hope that you enjoy our live demo. Entering the room, you can see the hardware testbed. The testbed is summarized by this system block diagram, and in this particular scenario, we are using a single transmitting source to demonstrate our proposed direction of arrival estimation algorithms. For the scope of this project, we are assuming that all signal characteristics are known except for the signal's location. On the host computer, we are using LabVIEW to interface with the USRP 2901 and transmitting our signal. On the front panel of LabVIEW, the various simulation inputs allow us to control the signal parameters. In this case, we're using a carrier frequency of 1 GHz on the transmitting port of enabled channel 0. On the USRP 2901, you can see that our signal source is marked by the red indicator. In the future, we'll be using a second signal source, however in this case it is currently inactive. Moving to the table, you can see that we have a single omnidirectional antenna located at 90 degrees in real time with respect to the uniform linear array. These manually marked angles allow us to compare the accuracy of our DOA estimation algorithms. The receiving hardware is summarized by this system block diagram. As well, each component is summarized in our detailed report. The first object of interest is the 4-element uniform linear array. The ULA consists of 4 omnidirectional antennas, all separated by a distance lambda over 2 in order to avoid intermutual coupling. As well, the 3D model for the ULA base allows us to adjust the antenna spacing. Located directly behind the ULA is a 4-way splitter. The 4-way splitter allows a reference signal to be injected into each USRP and therefore allows us to calculate a phase offset between each received signal. The outer USRPs are responsible for receiving signals at the ULA as well as the 4-way splitter. The outer TX ports marked by the green indicator light are connected to the ULA, while the inner RX ports are connected to the 4-way splitter. The center USRP is used for transmitting a reference signal into the 4-way splitter. The LabVIEW code for this USRP is the same exact as the transmitting end of the hardware testbed. Directly behind the USRPs is an octoclock and wave function generator. The octoclock performs time synchronization among the received signals, however it does not have a local oscillator internally and therefore requires a 10 MHz input and pulse per second input, which is being supplied by a wave function generator. Finally, on the host computer, we are using LabVIEW to perform all signal processing as well as our direction of arrival estimation algorithms. On the upper left-hand corner, you can see the received signals and their phase offsets. As well, on the bottom, you can see us synchronizing those signals. On the right-hand side, you can see our 4 mathematical models for performing direction of arrival estimation. As you can recall from earlier, our transmitting signal is located at 90 degrees, so we are effectively DOA estimating at this point. In a secondary test, we tried moving the transmitted signal to various angles to see if our algorithm would accurately estimate its location. As you can see, some angles do not accurately estimate as well as others. Due to this, as well as our limited testing environment, we believe that we are dealing with the multipath and reflections of the signal within the room. Our next steps are to reduce this, as well as introduce a second transmitting signal and introduce a final direction of arrival estimation algorithm. On behalf of our team, we would like to thank you again for watching our live demo.